Today in our chapter 4 investigation, we cover lesson 2. This is a continuation from our discussion in class today. So we will do some quick practice with writing equations in function form. That again just means to solve the equation for y, or write the equation more specifically as y equals blah. So we know blah is a very technical term, but that just means take everything and push it to the right-hand side and get y isolated all by itself. So we should be able to use our process of simplify, isolate, solve to work towards getting the term with y isolated and then solving for y if necessary by dividing by the coefficient. So we did some practice in class, but we'll continue with these next 3 examples. Let's start by isolating the term with y by moving the term with x away. Now remember, if you don't recognize that this 3x is positive, you can feel free to put a plus sign out front. That's going to make it a lot clearer that you're going to have to subtract 3x on both sides. In doing so, your 3x cancels out, and you will get 2y equals negative 3x plus 15. We have the term with y isolated, but now we want to solve for it. So what that just means is use inverse operations. So if 2 is being multiplied by y, then what I need to do is to divide everything by 2. Now everything means divide all the terms in the equation by 2. So the 2's are going to cancel, and you get y. This is where things will get a little tricky until we just get used to it. We're going to leave this as a fraction. Negative 3x over 2, I can leave as a reduced fraction in improper form as I need to. So I can just say that's negative 3 over 2. We can say that's times x. And this is also something we're just going to have to get used to. We're going to leave the 15 over 2 as long as it's reduced as an improper fraction. So we can say plus 15 over 2. So we're beginning to see that we're now gaining the freedom to actually cut some final work out of the process. I think the more we do this, the more you'll see that you'll be a lot happier knowing that you don't have to do the division of this fraction to either convert it to a mixed number or to decimal form. So this is our final answer. 3x plus 2y equals 15 is now going to be rewritten solving for y, or written in function, I noticed a typo there, function form, as y equals negative 3 halves x plus 15 halves. So let's do the next one. Again, we'll isolate the term with x first. So that, I'm sorry, the term with y first. So that means in this case I have to undo the minus 2x, which is by adding 2x on both sides. The x terms cancel out. You can see I get 4y equals. Another important thing, when we get to the right-hand side, I always want to lead with the variable term. So we're not going to say 20 plus 2x. We're going to say 2x plus 20. And you notice that's what we did over here as well. We said 2y equals negative 3x plus 15 instead of 15 minus 3x. We now need to finish solving for y by undoing the fact that it's being multiplied by that coefficient. So we'll divide everything by 4. So the 4's cancel. I'll get y. In 2 over 4, we can see that reduces. We can leave it in fraction form. We can say 1/2 x plus, and we know 20 over 4 reduces. If we can reduce to an integer, we'll do that. That becomes plus 5. So y equals 1/2 x plus 5y. We have one more example for you to do. And the only reason why I'm actually going to do this last one with you is because of the fact that we've got that 2/3. I want to show you how we're going to work with that. So first thing, undo the minus 5x to isolate the 2/3 y. You should all be seeing you can add 5x to both sides. The x terms cancel, and I get 2/3 y equals, now remember, we're going to lead with the variable term, 5x plus 16. Now this one's a little trickier, so I'm actually going to put a star next to it, because we have to undo the dividing, or we have to undo the multiplying by 2/3. We would normally divide by 2/3 here, wouldn't we? We divide by 2/3, we divide by 2/3, we divide by 2/3. Now what that actually means is that because we're dividing by a fraction, we're going to have to think about KCF here, aren't we? Okay, so that's key. So I'm going to show you how we're going to approach this in the most efficient way as possible. So if you wrote down everything that I just put in red, get rid of it, erase it. Okay. And I want you to wrap this entire equation in parentheses. And since we're going to have to divide by 2/3 and thinking about keep, change, flip, that means I'm going to have to multiply everything by 3/2. Now you should begin to notice that this is essentially getting set up for doing the distributive property. We're going to distribute there once. Well, we're going to distribute there twice. We're going to distribute one more time because there's 3 terms in this equation. So that's the equivalent of dividing each term in the equation, each piece in the equation by 2/3. We're going to multiply by 3/2. So the goal of that, the key with that, is that it gets this to cancel. We should know that. 3/2 times its reciprocal, 2/3 equals y. Equals. Okay, well, let's see. 5x times 3/2, there's no canceling. I can think of that as 5/1, so I can't cross-cancel the 5 and the 2. I can't cross-cancel the 3 and the 1, so I'll just multiply my numerators across. 15, my denominators across 2x. And then I'll distribute one last time. 3/2 times, I can think of that as 16/1. Well, I should be able to see that I can cross-cancel the 2 with the 16. That's going to become an 8 here. That's going to become a 1 there. And then I can multiply numerators and denominators across. So 3 times 8 is plus 24/1. So this becomes y equals 15/2x plus 24. So this one's a little trickier, and you're going to have to just get more practice in with those to get comfortable. Okay. So last thing we're going to do is to actually convert these equations into function form. And then we're going to pick some ordered pairs so that we can substitute in for x and we can solve for y. And once I have an x and a y value, I have ordered pairs. I'll have ordered pairs for 1, 2, 3 points. I'll have an x and a y, one ordered pair. I'll have an x and a y, another ordered pair. I'll have an x and a y, a third ordered pair. And I can plot all 3 of those points and graph a line. Okay? So we'll start by solving this equation for y. Remember, we're going to get y equals our very technical term blah. So we'll subtract x. We'll get 2y equals, now if you don't like negative x, you can think of it as negative 1x for now. We'll clean that up later. Plus 4. And then to finish solving, we'll divide by 2, divide by 2, divide by 2. And I'm going to get y equals negative 1/2 x. That's that negative 1/2, negative 1/2 x, plus 4/2 is just simply plus 2. Okay. So from here, we have to begin to recognize that we have the freedom to pick any ordered pairs that we want, any values of x that we want, so that we can begin to create ordered pairs. But you should notice you don't want to pick values because of this fraction that are going to leave you with fractions. So I want to think about what types of values for x will get me into the world of integers. And we should be able to see that if I choose any even number for x, because I have the freedom to pick whatever I want, when I take half of it, I'm going to get something that's not in fraction form. So I'm going to tell you to randomly pick, well, I'm going to tell you, but if you were doing this on your own, you would randomly pick values. I'm going to ask you to pick -4 for x. I'm going to ask you to pick 0 for x. And I'm going to ask you to pick 2 for x. So let's see if we can do this math in our heads. What's a negative times a negative? We know that's a positive, okay. So what's half of 4? 2. So that gives me 2. -1/2 times -4 is 2. Plus 2 is 4. That will give me the ordered pair. If I think about x comma y, that will give me the ordered pair -4, 4. I'll be plotting that point shortly. Now we're going to put a new value in for x because we have the freedom to pick what we want. I'm going to put 0 in. Well, anything times 0 is 0. Add 2, I get 2. Notice all I'm doing, I'm following order of operations. I'm multiplying and then I'm adding. So my next ordered pair is 0, 2. And then we're going to do this one more time. I'm going to do -1/2 times 2. I know I'm going to get something negative. Let's see, that's going to give me -1. When I add 2 to that, I'm going to get +1. So that's going to give me one more ordered pair, 2, 1. So now I have 3 ordered pairs that I can graph on my, or plot on my coordinate plane. So the first point we're going to plot, is -4, 4. That means starting at the origin, go 4 to the left and 4 up. Plot that point. The second point, I'm not going to move right or left from my x, but I am going to move up to on the y-axis. My points are doing a good job of disappearing on me. Oh, there we go. There we go. And then the last ordered pair I'm going to plot is 2 to the right of the origin, comma 1. So there we go. You notice these points fall in a nice straight path, which means that they form a line. So I don't have the ability to use a ruler here, but you will use a ruler and you will draw, better than I can hopefully draw right now, a nice straight line through the 3 points that you plotted, and you're now getting the end result that is a graph line for this equation right here. So you are coming up with a line that represents the infinite number of points for this equation. We just happen to find 3 of those infinitely many points. So your job is going to be to finish this last problem on your own. And I'm going to have you think your way through picking the appropriate ordered pairs as needed so that you don't wind up with fractions here. And then when you're ready, you will pick, or you will plot those points and you will graph your line. And we will check back in tomorrow. So this is a really long video today, okay? But it walked you through and gave you some additional practice with writing equations in function form by solving for y equals blah. And it extended that to, after you write the equations in function form, it extended it into finding ordered pairs for the equation so that we could plot those ordered pairs and graph the line. So we'll do more practice with this in class tomorrow, but this should be a good starting point for you.